All right, good morning. Today we are going to look at what it means to be continuous and also the intermediate value theorem. So here in the warm-up it says that we just want to draw a graph where f of 2 is equal to the limit of f of x as x approaches 2. And then we're also going to draw a graph where it does not equal. Okay? So on this first graph, I don't know, maybe I've got a function that's not going to be beautiful, but let's see, I don't know, maybe it goes like that. Okay, so here on this, I have the point at 2, 3, it looks like. Okay, so in this graph, f of 2 equals 3, right? So we would say in this graph, f of 2 equals 3, but also the limit exists because as I approach 2 from the left, I'd be coming in at 3, and also when I approach 2 from the right-hand side here, I would also be approaching 3. So that is a case where f of 2 and the limit of f of x as x approaches 2 are the same. And then next to it, I'm going to draw one where they are not the same. So here, I'm going to put an open circle. Oops, sorry. No, that doesn't look quite like an open circle. But I don't know, maybe we have an open circle right here, and it's going down that way. And then up here, I don't know, I'm going to put a closed circle, and this guy's taking off up and to the right there. So in this case, f of 2, right, the y value at x equals 2, because this is a closed circle, this wins, so it would be 4. But the limit, well, the limit as I approach from the left is going to be negative 2 or 3 there. And then as I approach from the right, it'll be that 4 value again. So here, the limit does not exist. So it turns out there's actually a mathematical term for a function when they are the same. So if when you evaluate the function it's the same thing as the limit, we say that that would be continuous, okay? And continuity is going to be important. A lot of times they will ask you, what it takes for something to be continuous, etc. Okay? So there are 3 main rules for continuity. You will need to know these. So absolutely write these down, put a star next to them, do whatever you need to do to let yourself know that these are important. So for it to be continuous, first of all, f of a has to exist. What does that mean? It means that on that last example, okay, when I was back here, looking at this one over here, if these were both closed circles over here, like if this was a closed circle, that would have been bad because there would have been no f of 2. So f of whatever has to exist, okay? And the second rule is that the limit as x approaches a of f of x has to exist as well. So you have to be able to evaluate the function there, and the limit has to exist. Okay? And then the key in it all is that they have to be the same. So you would say that the limit as x approaches a of f of x has to equal the function if you evaluate it at that same spot. So those are your 3 rules. It's super important that you know them. When a function is not continuous, we say that it is discontinuous. That's the proper word to use there. So we say that it's discontinuous. Perfect. All right. Okay. So let's take a look at, how that looks in words. So a function y equals f of x is continuous at a left endpoint a or a right endpoint b of its domain if the limit from the right and the left are both the same. Okay. Notice here that you can be continuous at an endpoint. That's kind of a tricky concept there. So you can be continuous at an endpoint. You don't see it a ton, but just in case. And then it says here, if the point we're looking at is an endpoint, then you're only looking at the one-sided limit, okay? So if you're looking at the endpoint, say they give you a graph, it's a piecewise function, and they ask you if it's continuous somewhere on there, then, and it happens to be, the most left point or the most right point, you can still be continuous. You're just looking at the limit from one-sided. So yeah, a function can be continuous or discontinuous at a single point or over an interval. And this is what it means in the graph. So if you're given the picture The graph is continuous can be drawn without having to lift your pen or pencil from the paper. Notice this is not an acceptable answer on a test. You will need to show all 3 of the rules for continuity on the test. So on a test, if you're asked to prove that something is continuous, you're going to go back to these 3 rules. First, you need to show that f of a exists. You need to show that the limit exists. Then you need to conclude that those 2 things are equal to each other. That's how you get your credit on the test. So to find where a function is continuous, first we find where it's discontinuous and then exclude all of those points. Now there's a slight typo, not really a typo on your paper, but at the very bottom there, those are supposed to be unions. The math type didn't kind of enter those right. I think the symbol came out a little bit weird on your paper, so go ahead and correct that into the U's, just like it's a union. So in this example, say the denominator would end up being 0 if you plugged in -5 or if you plugged in 1. So we would say the function is continuous everywhere else. Well, yeah, this whole thing is actually a little off. We're going to change it because all the symbols got messed up. So let's go ahead and get rid of that. This should read -infinity. So if it's continue everywhere else, that means from -infinity all the way to 5, parentheses, union, and then -5 to 1, union, 1 to infinity. That's how that should be written there, but the math type came out a little bit goofy. So go ahead and correct that on your paper. Okay. So this is basically saying that this function would be continuous everywhere except for -5 and +1 there. Okay. All right. Let's take a look at a graph and see if we could determine continuity. All right, so this is a graph of a piecewise function. So when I'm looking at it here, right, I have this part's going down, I have a constant, there's a point up here, an open circle, increasing then decreasing here. And we're asking if it's continuous at all these different points. Okay, so all these different points. And then down here, basically it's asking us to write an interval notation where it is continuous overall. Well, remember, you don't need to justify using the right and left-hand limits. You don't need to like show that algebraic work if they give you the picture. So here, at x equals 3, okay, I'm thinking about, all right, if I'm on this graph and I'm coming from the left and I'm coming from the right, I approach the same number there. It looks like it's going to be a y value of 2. So here, yes, it exists, and it is 2. So we would say f of 3 equals 2. Why? Because if I just plugged in, notice it's a closed circle there, right here. F of 3 equals 2. Okay, so it's a closed circle. So that part exists. Now, I need to show that the limit exists. So the limit as x approaches 3 of f of x also equals 2. So since those 2 things are the same, okay, so notice that 2 equals 2, so that tells me that yes, it is continuous. Yes, it is continuous. I'm just going to abbreviate that because I'm running out of room. Okay, so now we're going to do something very similar, but now we're just going to look at x is 0. So this time, first f of 0 has to exist, right? So let me just grab a pen here. So at 0, okay, the y value is 1. So we would say something like f of 0 equals 1. I'm evaluating the function at x equals 0 and I got 1. Then I need to check the limit. Okay? Now this is an example of one where there is an endpoint. So since there's nothing to the left of it, I can only take the one-sided limit. So here the limit approaches 1 as well. So you would say the limit as x approaches 0 from the right is 1. So that has to exist, right? So the limit, okay, as x approaches 1, and I'm going to indicate that it was a one-sided limit by doing that plus sign. So from the right of f of x equals 1. And so yes, this one is continuous, okay? Notice that when you evaluate, right, and the limit exists, and those are the same, so we would say yes, this one is continuous. Okay, so this one is continuous. Continuous there. All right, take a minute and see if you can come up with if the rest are continuous or not.